Yeah. Good evening, children. Good evening, online students.
Good evening, ma'am.
Good evening.
Good evening.
Good evening.
Good evening, ma'am.
I've shared. Good evening, children. I've shared my screen. Is it visible?
Yes, ma'am.
All right.
Yes, ma'am.
All right. Good. Just leave about 2 pages. If it's a long ruled book, leave 2 pages. Small book, then 4 pages, and continue. We're continuing with trigonometry. If you're using a long notebook, 2 sides. 2 sides. Small notebook, 4 sides. You can leave one extra, no problem. 2 sides, 3 sides, it's okay. Yeah. Now take down this question. No. Actually, okay, let me tell you how we're going to go about today's class. All right. So I'm going to, online students, please listen to this. So I'm going to explain a bunch of questions till 7:30. After that, I'll put you to write because I have another class from 7:30. I couldn't make a couple of classes last week due to my daughter's admissions. So I have to compensate all that. So I have another class from 7:30 to 9:30. So what I'm going to do is 6:30 to 7:30. I'm going to teach you, and instead of making you write during the meaning immediately as soon as I answer the explain the answer, I'll explain a bunch of it, and then you can start writing everything. All right. So 1 hour we just want to listen. Any doubts, get it clarified right away. Then you can write it. So close your books for now and listen to me carefully. Now this is the first one. Online students will not leave the meeting. You will be in the meeting till 8:30. You will not leave the meeting. I will be explaining only till 7:30. After which you will be writing whatever is explained from 6:30 to 7:30. But we'll stay in the meeting till 8:30. All right. If cos theta is equal to 3/5, find sine theta. If cos theta is equal to 3/5, find sine theta. All right. So see here, very simple. You need to take up a right triangle. You need to take up a right triangle and mark off any acute angle as theta. You can even name the triangle ABC, all that is your choice. PQR, whatever. It is a right triangle and mark off the right angle. Now you can see that these are the remaining two acute angles. These are the remaining two acute angles. Mark off any one of the two acute angles as theta. Any one, either this is theta or this is theta. Any one. All right. So that's the first step. Now, what is given? Cos theta is equal to 3/5. And what is cos theta? Adjacent by hypotenuse. So adjacent by hypotenuse is 3/5. This is theta for this angle. See, opposite and adjacent are always understood with respect to the angle. Okay, so for this angle theta, this is the opposite side and this is the adjacent side. This is the hypotenuse because it's opposite to the right angle. So cos theta, so this is what? Adjacent by hypotenuse. So adjacent, this is 3 and this is 5. All right. It's a ratio 3/5. So this one AB is 3 parts, AC is 5 parts. Is this understood? And now by Pythagoras theorem, you can find BC and that will be 4, right? Correct? By Pythagoras theorem, you'll find BC and that's going to be 4. Now find sine theta. What is sine theta? Opposite by hypotenuse. And opposite is 4, hypotenuse is 5. So the value of sine theta is 4/5. You can do this in 2-3 ways. This is one of the few methods. So we'll do that in the next class. I gave you the reason for that. So otherwise, I would do the other methods also as now itself. But I've done everything here. Okay. All right. For this alone, I don't have the solution, so I'm just working. So ABC, right angle. We are marking this as theta, opposite side, adjacent side, hypotenuse, and cos theta is equal to 3/5. And that is what? Adjacent by hypotenuse. Correct? So adjacent is this one. This is 3 and this is 5. So BC is equal to BC square plus, you can write all that AB square is equal to AC square. So BC square plus 3 square, 9 is equal to 5 square, 25. So BC is equal to 25 minus 9, 16, square root of 16, which is 4. All right, so BC is 4. So now you have the triangle like this. Theta, ABC, 3, 4, 5. So sine theta is equal to opposite. So that is 4 by 5. So this is about the first one. Next one. If sine theta is equal to A by B. Okay, now you can try it. Let me give that work to you. You can try it like this. You can also use identity. What's identity? Sine square theta plus cos square theta is 1. Alternate method. You can do it. Okay, not now. Alternate method is you can use the identity. Sine square theta plus cos square theta is equal to 1. Now we can substitute the value of cos theta here and find sine theta. You can also do this. Correct? So this one you completed. This alternate method, you try it yourself. Online students? Got the first one?
Yes, ma'am.
All right.
Yes, ma'am.
Alternate method is you can use the identity sine square theta plus cos square theta is 1. Substitute the value of cos. You don't need the right triangle. You don't need all this. This is independent method. This is an independent method. Substitute the value of cos theta and find sine theta. Okay. So here, given that sine theta is equal to A by B, find secant theta plus tan theta. So here also you can use the triangle method. Okay, so sine theta is A by B. Okay, it's given that sine theta is equal to A by B. And what is sine theta? Opposite by hypotenuse. Opposite by hypotenuse is A by B. So opposite this one is A. Hypotenuse is B. Then we'll find BC. What is BC? BC will be equal to what? Square root of AC square minus AB square, correct? So that is equal to square root of AC square, B square minus A square, B square minus A square. Okay, this is BC. Okay, this is BC. Now what should you find? We need to find secant theta plus tan theta. We need to find secant theta plus tan theta. Now what is secant theta? So when you have this right triangle, you need to find the missing side using Pythagoras theorem. From the ratio, you can fill two sides. That third side you should find using Pythagoras theorem. And that's what we found here. BC is equal to root of B square minus A square. Now we have all the three sides. Only when you have all the three sides, you are ready to answer the question given there. So now we need to find secant theta plus tan theta. So let's write secant theta first. Secant theta is what? Hypotenuse by secant theta. Hypotenuse by adjacent. So you can so it's hypotenuse by adjacent. Here, what is it? What is it here? Hypotenuse AC by adjacent BC. That is B by BC. Root B square minus A square. Root B square minus. Secant theta is hypotenuse by adjacent, which is AC by BC. Correct? Which is B by root of B square minus A square. Yes or no, children? Okay, next we need to find tan theta. What is tan theta? Opposite by adjacent. See, this is just for your reference. You may see this one. You can even omit writing. You should write this and this. This is just for our reference. You can straightaway start with secant theta is equal to AC by BC. Secant theta is equal to AC by BC. Tan theta is equal to, you can write the sides directly. Okay, so opposite is AB. By adjacent is BC, correct? So AB is how much? AB is A and BC is root of B square minus A square. Next step, we have to find secant theta plus tan theta. So secant theta plus tan theta is equal to add B by root B square minus A square plus A by root B square minus A square. So that is equal to common denominator root of B square minus A square and then A plus B. A plus B. You can actually leave it here, but if it is for 4 marks, then you have to rationalize the denominator. You'll have to rationalize the denominator. You can leave it here. 2 marks, you can leave it here. If it won't be for 4 marks, but if at all it is, you'll have to rationalize the denominator. I think I've done it here. Yeah, good, I've done it here. So that's what you see here, children. So this is the triangle method. What I've worked here is the triangle method. When one ratio is given, listen carefully, children. Online students, please listen carefully here also. When a ratio is given, okay, you need to take up a right triangle. Mark off any one of the 2 acute angles as theta or alpha, whatever is the angle there. And with respect to that, you should mark the opposite and adjacent side. With respect to that angle theta, you must mark the opposite and adjacent side. Opposite adjacent, we don't write simply somewhere. With respect to that angle, for that angle, which is the opposite side. So for that angle, if one is the opposite side, the other one will be the adjacent side. Hypotenuse is fixed. Okay, so that's the first step. When a ratio is given, draw a triangle and fill all this. Then find the missing side using Pythagoras theorem. Find the missing side using Pythagoras theorem. Then find the ratios. All right. So now secant, why did we find secant theta? Because we'll have to find secant theta plus tan theta, no? So we'll find secant theta, we'll find tan theta, and then we'll find secant theta plus tan theta. And we know the ratio. Secant theta is hypotenuse by adjacent and number. Now I told you, after this, you may have to rationalize the denominator if it carries more marks. Okay, so that you can see here. Yeah, you can see it here. You can see it here. Till here I explained. Till here. And then you can see the rationalizing part here. This you can understand. Rationalizing part you can see here. This is optional. But again, you know, we are always scared, no, in the exam, even for 2 marks, if she reduces mark your teacher. So if you have time, you finish it till here. That's what I would do if I were in your place. If it's irrational in the denominator, rationalize it so that you're safe. People don't understand, you know. Yeah, children. Is this understood? This is one method. And here I have found, secant theta and tan theta using trigonometric identities. For the same question, you have 2 answers. We are talking about this question. This one. For this, I've given you 2 answers. One is this triangle method. One is the triangle method. The other is using identities. Okay. Now, how am I? So look at the alternate method. Now I have to find secant theta. But I have sine theta with me. With sine theta, I can find cos theta. With sine theta, I can find cos theta. But I don't need cos theta, I need secant theta. It's okay. With sine theta, I'll find cos theta. And the reciprocal of cos is secant. So I can get secant that way. Correct? And then I need to also get tan theta. And you know that tan theta is sine theta by cos theta. You know sine theta, you know cos theta. Divide, you will get tan theta. See, again, this is not a fixed method. You can do it using different identity also. This is my idea here. We have to find secant. So this method is not using the right triangle, but using trigonometric identities. When such a question is given, that is when you're given one ratio, like sine theta is equal to A by B. This is a trigonometric ratio. Sine theta is equal to A by B is a trigonometric ratio. When you are given a trigonometric ratio, there are different approaches to answer the question. One is the triangle method. You can draw a triangle, mark the acute angle, and fill the two sides, find the third side using Pythagoras theorem, and then find the ratios and proceed. That's one way. The other way is using identities, trigonometric identities. This is that second method. So sine theta is a by b. We need to find secant theta, but I can find cos theta. So I'll find cos theta, and the reciprocal of that is secant theta. Is that fine? And once you find secant theta, how do you find tan theta? Tan theta is sine theta by cos theta. This is sine theta. See here, this is sine theta because that's given. Divided by cos theta. This is cos theta. Where is it? Yeah, here. This is cos theta. See, children, this is. Okay, 1 minute. Let me write this. How in the interpretations of trigonometric ratios, I have given this cos theta is root of 1 minus sine square theta. If you're wondering how I've written that, see here, sine square theta plus cos square theta is 1. So cos square theta is equal to 1 minus sine square theta. So cos theta is equal to square root of 1 minus sine square theta. Correct? Sine square theta plus cos square theta is 1. Cos square theta is equal to 1 minus sine square theta. That is cos square theta. So cos theta is equal to square root of 1 minus sine square theta. I have written that straight away here. That you can write it like this. You can write it straight away like this. Using the identity, cos theta is root of 1 minus sine square theta. So I've substituted and I found cos theta. Reciprocal is secant theta. Tan theta is sine theta by cos theta. So divide and I got tan theta. Now I add. I get this. Denominator is irrational, so I rationalize the denominator. There is another method also. I'll tell you when we come across a question like that. So what are the two methods we have learned so far? You must remember like this. When you're given a trigonometric ratio, you can approach the answer in two ways. One is using a right triangle. The other is using trigonometric identities. When you're using a right triangle, it's important to mark off the acute angle. And with respect to that, opposite and adjacent. That's the first step. Then fill. From the ratio, you can fill two sides. From the ratio given, you can fill two sides because that ratio will be opposite by hypotenuse or adjacent by hypotenuse. So you can fill two sides. So first find next find the third side using Pythagoras theorem. So now you are ready. Now see what ratios you have to find to answer the question. Like here, secant theta and tan theta. So find that and then add. This is the triangle method. Without using the triangle is using trigonometric identities. So again, you should write an appropriate identity to find secant theta. So here I've written for cos and reciprocal to find secant. And to find tan, I've written sine by cos. So like this, we find secant theta, we find tan theta, and then we perform secant theta plus tan theta, and then we rationalize the denominator because the denominator is irrational. So when you're writing the first method, you'll have to write the, see, this is the first one. You should write this and then try the alternate method for the first one. Okay, for the second one, I have worked both the methods. For the second one, I have worked both the methods. This is one method and this is the other method. Both the methods are here. Third one. If theta be an acute angle and phi cosecant theta is equal to 7. So see, if phi cosecant theta is 7, that means cosecant theta is equal to 7 by 5. See, it's like 5a is equal to 7. So a is equal to 7 by 5. 5a is equal to 7. If you have 5a is equal to 7, then a is equal to 7 by 5. Similarly, 5 cosecant theta meaning 5 into cosecant theta. 5 cosecant theta meaning 5 into cosecant theta. But I told you that cosecant theta is not cosecant into theta. Cosecant theta is not cosecant into the theta. Cosecant theta is not the product of cosecant and theta. Cosecant theta is one thing. Nothing is separable there. It's one unit. But when you say 5 cosecant theta, it is 5 into cosecant theta. 5 into cosecant theta is equal to 7. So cosecant theta is equal to 7 by 5. So that's what, so we have cosecant theta 7 by 5. So now listen carefully, children. You can use the right triangle. What is cosecant theta? Now what we are discussing now is not on the slide. In the slide, it's a different method. The identity approach. The triangle approach, I'm telling you orally now. In the slide, you see the identity approach. Now the triangle approach, cosecant theta 7 by 5. So what is cosecant theta? Hypotenuse by opposite. Hypotenuse by opposite. So you must do it in both ways, children. Okay, so alternate method, you should take up a right triangle. You must take up a right triangle. Say this is theta. If this is theta, what is given? Cosecant theta. Cosecant theta is equal to 7 by 5.
7.
Somebody's mic is enabled. Disable your mic, children. Okay, so 7 by 5, right? 7 by 5. What is this? Hypotenuse by opposite. For theta, this is the opposite side. And this is the opposite side. And this is the adjacent side. And this is the hypotenuse. This is the hypotenuse. So hypotenuse is 7. And the opposite side is 5. So you should find the adjacent side using Pythagoras theorem. Okay. ABC, correct? So you have AB is equal to, by Pythagoras theorem, AB will be square root of AC square minus BC square. So that is square root of 7 square minus 5 square. 49 minus 25. So square root of 24. And you can write it as whatever. Sorry. All right. So that's about AB. That is about AB. Now we'll answer these ratios. What is sine theta, children? What is sine theta? Opposite. Sine theta is the opposite. That is BC by AC. That is 5 by 7. Then what is cos theta? What is cos theta? Adjacent AB by hypotenuse AC. So that is root 24 by 7. Then that's it. So we have to find cos square theta. What is cos square theta? Cos square theta will be equal to of 24. No. No. We found cos theta, right? Next we have to find cos square theta. And that is cos theta the whole square. So 24 by 49. Now we have to evaluate. What is that? What is that we'll have to evaluate? We'll have to find sine theta now. Now sine theta plus cos square theta minus 1 is equal to, what is sine theta? 5 by 7. Plus cos square theta 24 by 49. Then minus 1. Minus 1. You'll have to find that. Don't see this. Don't see this one and ask any question. Don't ask anything from this. Is this understood? So what is it here? We are given 5 cosecant theta is equal to 7. That means cosecant theta is equal to 7 by 5. That's the first step. So we know that whenever we have a ratio, we'll have to use a right triangle. Correct?
Okay.
Sorry. Yeah. So we know that whenever we have a ratio, we have to use a right triangle. Correct? So you can see the right triangle here. Yeah, you can see the right triangle here. Mark of any angle is theta. So you know the procedure, right? That. What's the ratio we have? Cosecant theta is equal to 7 by 5. Cosecant theta is equal to 7 by 5. All right. So right triangle, find the missing side. And then why did we find sine theta, children? Because we have to find sine theta. Why did we find cos theta? Because we'll have to find cos square theta. So we find sine theta and cos theta, correct? And then square it to find cos square theta. Square that to find cos square theta. Then substitute the values and simplify. I haven't simplified. You'll do that. Now coming to the alternate method. What you see here, the alternate method, what you see here. So here what I've done is, what is cos square theta minus 1? What is cos square theta minus 1? 1 minute. See here, children. No. Sine square theta plus cos square theta is 1. What is cos square theta minus 1? Cos square theta minus 1 is equal to minus sine square theta. Yes or no? See it? Sine square theta plus cos square theta is equal to 1. Cos square theta minus 1 is equal to minus sine square theta. Minus sine square theta. So I've replaced this one with minus sine square theta. Now in the question, it's given that cosecant theta is 7 by 5. Reciprocal of that is sine theta. What is sine theta? 5 by 7. So if sine theta is 5 by 7, what is sine square theta? 5 by 7 the whole square, 25 by 49. So substitute and do it. You don't need triangle at all here. And identity also. Yeah. So the identity also you'll have to be very careful. Cos square theta minus 1 is minus sine square theta. Cos square theta minus 1 is minus sine square theta. So that's what I've written here. This one is this, and the reciprocal ratio sine theta is 5 by 7. And after that I've written this one is nothing but sine square. Sorry, this one is nothing but sine theta, and this is nothing but minus sine square theta. I've given the reason below because sine square theta plus cos square theta is 1. This implies cos square theta minus 1 is equal to minus sine square theta. I've given the reason below. This one is this one. It's a reciprocal ratio. Then since sine square theta plus cos square theta is 1, when you transpose cos square theta minus 1 is minus sine square theta. So here in this expression, the sine theta as it is, cos square theta minus 1 is minus sine square theta. So that's nothing but sine theta minus sine square theta. So now substitute. What is sine theta? 5 by 7. Sine square theta is sine theta the whole square. Sine square theta, sine theta the whole square. So 5 by 7 the whole square. Simplify, you will get the same result. So the first method is using, okay, one method is using the right triangle, another using identity. See, now another thing I'll clarify this also. It's not that you should do this. It's not that you should do this, you know. You can even take it as sine theta plus cos square theta minus 1. Okay, you can even find the value of cos theta. How do you find cos square theta? What is sine square theta? 5 by 7. And we know that cos square theta is 1 minus sine square theta. You can even substitute that and get the value of cos square theta. I'm saying not that you should, you know, like replace. It is not that you should replace this one with minus sine square theta. Nothing like that. This is one of the ways. Otherwise, you can just find the value of cos square theta. How will you find the value of cos square theta? Cos square theta is 1 minus sine square theta. So 1 minus 25 by 49. And find the value of cos square theta and substitute that. Understood what I'm saying? No, right? And Arjun? Yes or no? The second method. Now, meaning that now what I said. Here what you see is I have replaced cos square theta minus 1 with what? Minus sine square theta. Why? Because we know cosecant theta. Using cosecant theta, we know sine theta. So I'm replacing cos square theta minus 1 with minus sin square theta. So we can use the value of sin theta and sin square theta. I'm saying it's not important, not that you should do it like this. You can also find the value of cos square theta. How? Sin square theta plus cos square theta is 1, no? So substitute the value of sin square theta. 5 by 7 the whole square plus cos square theta is equal to 1. So you'll find the value of cos square theta, right? You can even substitute that value here. So sin theta's value, cos square theta's value minus 1 and evaluate. Do all the methods now, children. All the 3 methods. That is, for this one, 3 methods. For this one, you should do 3 methods. One is what you see in the slide here. That is the paper slide. 1. 2 is what I've written, alternate method. 3, you're going to do by yourself by finding the value of cos square theta and substituting. 3 methods you must do for this. All the 3 methods will get the same answer. All right. Now, so this is the other one I said. Yeah. So this one, you want to do this yourself because you know it. I'll just help you get started. I'm calling this alpha, A, B, C. Secant alpha. Secant alpha is 5 by 4. Secant is the reciprocal of cos. Okay, so it is hypotenuse by adjacent. Hypotenuse by adjacent. For alpha, this is the opposite side. And this is the adjacent side. This is the hypotenuse. Now, hypotenuse by adjacent is 5 by 4. So hypotenuse, this one, by adjacent, 5 by 4. Now you'll find the opposite side using Pythagoras theorem. All right, so you'll get 3 there. Now what you should do is, you must verify that this one is equal to this one. So you should just find the value of tan alpha and tan square alpha and substitute here. Then you should take up this side. So you should work LHS and RHS. You must work LHS, RHS separately. Okay, so you should take up the LHS, substitute the values. Using the triangle, you can find tan alpha. Using the triangle. When you're using the triangle, use the triangle to find tan alpha. What is tan alpha? Opposite by adjacent. Opposite by adjacent. That's tan alpha. Don't use the trigonometric identity. When you're using triangle, when you use the triangle, don't use from the triangle, you can get all the ratios. From the triangle, you can get all the ratios. Okay, so you'll find tan alpha and hence find tan square alpha, work the LHS and work the RHS also. You should get the same answer. That means you're verified. All the 6 trigonometric ratios you can get, that is, one ratio will be given to you. With the help of that one ratio, you will make the triangle. Now, using the triangle, you can find all the remaining 5 trigonometric ratios. Now here you're given secant alpha is 5 by 4, right? So secant alpha is 5 by 4. Using this, you're going to you're going to draw that right triangle and fill the values. 5, 4, you'll fill. Then using Pythagoras theorem, you'll get the unknown side. So now you have only one ratio secant alpha. Now you can find the sin alpha, cos alpha, tan alpha, cosecant alpha and cot alpha using the right triangle. In fact, if you find sin alpha, reciprocal is cosecant. And if you have secant, reciprocal is cos. If you find tan from the triangle, reciprocal is cot. Everything you don't have to go to the triangle. For the same situation, if you have to find the remaining 5 ratios, if you find sine, you will get cosecant also. Now we have secant here. So reciprocal is cos. You find tan, reciprocal is cot. Also, when you have one ratio, you can find all the other 5 trigonometric ratios using the right triangle. So this you'll do by yourself. I don't have the answer slide. Now this is the next type. Okay, so in the next one, in this question, we are given that sine A is equal to √3/2. Okay. You can use it. So this one also, first method 1. You can use a triangle approach. Method 1, triangle approach. So what is a triangle approach? Using a triangle like this. Okay. A should not be the right angle. You should not mark A is one of the 2 acute angles. You should not mark A here. You must not mark A here. A is one of the 2 acute angles. So don't mark A here. So here it is A, no, so it is this angle. You don't have to mark theta and all that. Theta alpha, don't mark because it is this angle. A is this angle. A should be an acute angle. Don't mark the right angle as A. Okay, now for this one, so you know the opposite side, you know the adjacent side, and this is the hypotenuse. So sine A is √3/2, opposite by hypotenuse. So now you can find out this side using Pythagoras theorem. All right, then and hence evaluate 2 cot square A minus 1. Evaluate meaning find the value of. You must find the value of 2 cot square A minus 1. So find cot A using the triangle. Find cot A using the triangle. And then evaluate, substitute the value and simplify that. This is the triangle approach, correct? Okay. Next, method 2, this also you should do. Identity approach, trigonometric identity approach. No, see, these are the names I'm using. In the class, like in your school, don't say there are 3 approaches, triangle approach. We are using it to understand. These, meaning you will not find this in the textbook like these terms. Okay, we are just using to understand this. Triangle approach is one, trigonometric identity approach. So you need to evaluate what 2 cot square A minus 1. You need to evaluate 2 cot square A minus 1. Trigonometric approach. You have sine A. You have sine A. But you should find cot A. So you should use identity. Cosecant square A minus cot square A is equal to 1 because you can find cot from this. But we don't have cosecant, but we have sine whose reciprocal is cosecant. So you can find, see, in the 3 identities, one of it will definitely help you. See, we wrote this one, cosecant square A minus cot square A is 1. Now from this, we should find cot square A. We should find cot square A. Okay. But we need cosecant square A then. We don't have cosecant square A. But we have its reciprocal sine A. So sine A is √3/2. That means cosecant A is 2/√3. That means cosecant square A is 2/√3 the whole square. 2/√3 the whole square is 4/3. 4/3. We have it. So now when you substitute that, you will get cot square. What should you need? Cot square A. Find cot square A. Don't find cot A. Cot square A you find. Substitute and evaluate. This is the trigonometric identity approach. Triangle approach, trigonometric identity approach. Okay, correct? Okay. We understand why this identity helps you to find cot square A. Whenever you use an identity, one you have to find, the other one you should know. Navneet, point on that disturb us, Navneet. Another. Avnish, yeah, 9:30. Yeah. Oh my God. Yeah, children. Yeah, we have to find cot square A. So if of the two identities, one you have to find, the other one you should know. Both if you don't know, you can't do anything. One will be, 1 second. Yeah, the other one is what we have not seen so far, the other one. Now sin is equal to root 3 by 2. In the sine table, where will you find the value root 3 by 2? Where will you find the value root 3 by 2? Thank you. Bye. 0, 1 by 2, 1 by root 2, root 3 by 2, 1. Sine of
60
what
degrees,
is root 3 by 2? 60 degrees. Because sine 0 degrees is 0. Sine 30 is 1 by 2. Sine 45 is 1 by root 2. Sine 60 is root 3 by 2. Sine 90 is 1. So sine of some angle is root 3 by 2. Okay, so see here, this is third method, method 3. That answer is here. And this method 3 is here. This is method 3. This is method 3. All right. I'll just start here. Okay, so the third method, children. See here, sine A. Sine A is equal to root 3 by 2. Okay, you substitute root 3 by 2 with sine 60 degrees. Because we are writing the equivalent. Root 3 by 2 is also sine 60 degrees. Because on the other side also we have sine A. If on the other side we have cot, then if you have like cos A on the other side, you must write in cos. Both the sides you must have the same ratio. Then only you can compare. We have sine A on one side. On the other side, we have root 3 by 2. So root 3 by 2, you should try to write using sine. Sine 60 degrees is root 3 by 2. So instead of root 3 by 2, we are writing sine 60. Now on comparing both the sides, we find A is equal to 60 degrees. Don't cancel sine and sine. They are not, sine is one thing. It's not separable. You cannot, if you're cancelling like that, that means it's separate. Sine is separate, A is separate. You cannot cancel like this. Comparing both the sides. On comparing both the sides, A is equal to 60 degrees. On comparing both the sides, A is 60. Agree? Now we found A, no? Now we will have to evaluate what 2 cot square A minus 1. And A is 60 degrees. So it is 2 cot square 60 minus 1. Cot square 60 degrees. What is cot 60 degrees? What is tan 60 root 3? So cot 60 will be 1 by root 3. And cot square meaning whole square. That's all. So see here. So sine A is sine 60. So A is equal to 60 degrees. Now this is what we'll have to evaluate. But A is what? 60 degrees. Correct? And cot 60 is 1 by root 3. Why whole square? Because cot square 60 degrees. Yeah. Understood?
Yes, ma'am.
Okay. So whenever the value is a standard value, if it's a value of a standard angle, now for us 0, 30, 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees are standard angles. So if the value is one of the values of the standard angles, then you can use this method, not always. Now earlier we got 5 by 4 and 5 by 4. Now this value we don't have in the table. Then you cannot use this method 3. Method 3 we cannot use. This is method 3. Method 3 cannot, method 1 and 2 always you can use. Any situation you can use. Method 1 and method 2. This method only if it's a standard value. Otherwise you cannot use it. Because see here, if you try secant alpha is equal to 5 by 4. We don't have 5 by 4 in the chart, we don't have 5 by 4 at all. Then we cannot find alpha. In our syllabus, we don't have. When I say we can't find, we can find. We are not learning that. It is possible to find. You can use a third method. In our syllabus, we don't have that. Because in our syllabus, we only use the values of 0, 30, 45, 60, and 90. So we can't find. Otherwise, we can find. Okay, so for us, secant alpha is 5 by 4. We cannot use the third method. Method 3, we cannot use. Only with a standard value like this. So here we find the angle itself. We find if this value is in the table, we find the angle itself. And instead of A, we take the angle and we substitute the value from the table and evaluate. This is method 3. All right. I didn't miss anything, no? Okay. So this one. See here I've written the values of tan theta, cot theta can also be found using the right triangle. Right triangle always you can use. I've used the algebraic identities approach, not algebraic identities, trigonometric identity approach. I have used the trigonometric identity approach. You can also use a right triangle. You should also do that. I want you to do method 1 and method 2. That is the triangle approach and the trigonometric identity approach. I want you to do both the methods. Here you can see the trigonometric identity approach. Okay, you must also do triangle approach. So we are given sine theta as m by n. Sine theta is m by n. Evaluate tan theta plus 4 by 4 cot theta plus 1. So what values you need? Tan theta and cot theta. And we know that if we find tan theta, we can find cot theta. If you have tan theta, reciprocal is cot theta. So we are finding tan theta first. Okay, cot theta here. Cot theta we are finding. All right, so see here, cosecant square theta minus cot square theta is 1. We start with this identity. Cosecant square theta minus cot square theta is 1. We start with this identity because we are given sine, which means we know cosecant. And we can find cot. Working this, you can find cot. Cosecant square theta minus cot square theta is 1. Sine theta is m by n. So cosecant theta is n by m. And working this, you can find cot theta. And once you find cot theta, it's reciprocal is tan theta. So now we have found tan theta and cot theta. We'll have to substitute and evaluate. All right. So in the triangle approach, you should take up the triangle, mark the angle, mark the two acute angles as theta. Then fill m and n, find the unknown side using Pythagoras theorem. Then find tan theta and cot theta and substitute. So here I've taken the LCM. So what's the LCM here, children, after substituting? One of you online tell me. One of you online tell me what's the LCM for the numerator? Root of?
N square minus M square.
Correct. So then what will I have here?
M into root of N.
Why into M only? M has the denominator, no?
Yes, ma'am. M plus 4 into root of N square minus M square.
Correct. That's a numerator divided by LCM. Divided by, what's the LCM here? M.
Yeah.
M. So it will be 4 root of N square minus M square plus M. M plus M. Now I have written this as this numerator I've written here and this denominator I've written here with a division sign. This numerator I've written here. This denominator I've written here with a division sign. Then reciprocal. Division becomes multiplication and reciprocal. So what happens? Look at this expression here. M plus 4 root N square minus M square. Same thing here. M plus, you can see M here. 4 root N square minus M square. It's the same thing. This numerator and this denominator is the same. So M by root of N square minus M square. All right. Now method 3 we cannot apply here. Method 3 we cannot apply. Because, yeah. Louder, no? Cot theta? Cos theta is cot theta is equal to cos theta by sin theta. Yes. So how will you? No, 1 minute. Sin cot theta is equal to cos theta by sin theta. Okay. We have sin theta. Okay, 1 minute. So using the identity sin square theta plus cos square theta is equal to 1, you want to find cos theta first. Correct. You can find cos theta. Then you want to divide cos theta by sin theta and find cot theta. You can do. Correct. Yes, you can do that. You can use the identity sin square theta plus cos square theta is 1. Sin theta is given. So substitute and find cos square theta, cos theta. Then now you have sin theta and cos theta. You can divide sin theta by cos theta is tan theta. And reciprocal of tan is cot. You can do that also. I think this itself 1 hour is, you have lots, right? Correct? Yeah, I think we'll stop here. This one, maybe you can try by yourself. If supposing you finish, this you can try by yourself. Cot theta is 15 by 8. Any approach you can use, triangle approach or identity approach. Okay. I'll just stop the recording, children. 1 minute. Just tell you once again what you're expected to do. Online students, listen carefully. So this one, I don't have the answer slide for this. First one, correct? I have worked one method here. This method I've worked, this is one method. Alternate method I want, that is triangle approach I have worked. You should do the alternate, meaning the trigonometric identity approach, you have to do it. This one, I think I have both for you. I have both. Yeah. In this one, in the slide, you can see one method. Okay, in all, you should do 3 methods here. This one I've not done. So this is only one method. You should verify the LHS and RHS. So work the LHS, work the RHS, and show that they have the same result. Yeah, this also in 3 methods. This we just discussed.